Hi, Wild Bill. It's Sunday, 3rd of July. My air conditioner is kicked up to full keep Rommel cool in the desert mode. But I'm going to talk for a moment about sharks. I've been watching some video, some just marvelously taken. I mean, the views and the editing, marvelous. Soft, dreamy, new age music I could do without, but everybody else seems to need that in peaceful settings, so I'm going to accept it for purposes of argument and say that these videos are just marvelous, really. Lots of videos of great white sharks, some of them right off the beach, Myrtle, and, other places, and they're not hunting people. They don't care. A lot of these sharks in these areas are parts of breeding grounds. So these are very young sharks. Even the ones that look rather large are either giving birth or they are growing to the point where they can escape these coastal zones and go out and forage in the pelagic water column. Great white sharks are known for certain behaviors. Of course, a lot of that, no matter what we say, is acclimatization. Sharks of all natures, of many kinds, pelagic sharks, open ocean sharks, follow ships around. They sure do. And they seem to attack things that fall off those ships. They sure do, because for 10,000 years humans have been going across the sea and pooping and peeing and throwing garbage over the side. And sharks are looking for blood and rotten stuff. That's their programming. Sharks are the ocean's garbage men. So certain sharks, you'll see giant sharks eating a whale carcass because that's being a garbage man. You'll see other sharks tearing apart other carcasses and any kind of garbage. And bait balls, that's how you get them to come, is you get a big bunch of frozen fish and throw it in the water, or chum, toss it in the water, and it brings sharks up because they smell blood. Why? Where? What does this all mean? What is the system of instinctual behaviors that lead to unity, that lead the shark to its prey, or that lead the shark to its mate, or that lead the shark to whatever it is trying to do in its life inside of its brain, or its inclination, physically or otherwise? It's all, I think, about its nose. Sharks circle. They see each other. Great whites especially. A lot of what I'm going to talk about is great white behavior and the behavior of other large sharks that I have either read up on or seen video footage of and thought it over and come to my own conclusions. So don't blame science for what I'm about to say. Sharks circle. They circle for the same reasons dogs do. Very sensitive nose. Somebody's bumhole has a lot of data if you're a predator, especially if you're a social predator. You can tell things like, is that animal old? Is that animal sick? Is that animal young? Is that animal strong? Is that animal sexually receptive? Is that animal dead? These are all things that any shark would need to know. It would need to know it about any animal in its area. It would need to know it about any potential prey in its area. So an octopus-eating shark would like to know about the smells that octopi put out. Octopuses, however you're going to call it these days. I was taught something, say, oh, that's wrong. Then the people who are wrong are the people who taught me. I'm not wrong. I just have to overcome my ignorance, is all. So sharks, bigger sharks especially. I'm going to talk about bronze whalers and tigers and white sharks here in this grouping. Poor beagles, I guess. I don't know enough about them to be sure. But they are known, some of them, for being found around whale corpses. Right? And you'll see that other sharks pretty much get out of the way when the big great whites show up. They are the privileged shark. Even big tigers will get out of the way for a big great white shark. Why is that? Don't know. Tigers are known to both eat carrion and garbage and to also hunt for prey actively. So a big tiger is a scary predator. But tigers will get out of the way and let the big great white sharks in. Now, these sharks are known for following whale pods or for frequenting areas where whales gather or reproduce. And there are reasons for this. From those whales, if you follow a whale pod, bronze whaler sharks are known for following whale pods. Why? Well, because every whale poops, and there's a lot of data in that poop. If you're a dog or a shark, how old is that specimen? What's it been eating? Is it healthy? Is it old? As I said, is it sexually receptive? Is it weakened because of something going on? And if you're a bronze whaler shark or a great white or any of the sharks that do trail whale pods, you'll be like, oh, there's a sick whale today. There might be dinner. Because after the whale dies, something's got to move in and clean it up, right? And if you're following the whales around, there you are. So I don't think these are necessarily behaviors that you can attribute to high intelligence, even though I find sharks fascinating. And I find great white sharks especially fascinating for several reasons. One of which is size and power. Another of which, of course, is its choice of prey items, which in some great white sharks sort of specialize in mammals. I call that the warm gush. There's a big difference between biting into a tuna and getting that lovely, delicious tuna flavor and tuna blood, right? And biting into a whale and getting that gorgeous gush of over-oxygenated warm blood. I bet sharks love that running through their gills. So anyway, I think the big predatory sharks that prey upon specialized prey. Some sharks specialize in tuna. Some sharks specialize in other fish or marine mammals. Now, it doesn't mean that they are above preying on items outside of what Bill says they like, right? Don't see any reason why a great white shark can't snap a cod out of the water for once, but you know, it's hovering around that island full of seals for a reason. Because those seals are pooping and peeing and giving birth, and there's blood all through the water, and it's going to drag every big shark that likes warm mammals to the area, because you can tell, follow your nose. So there are a lot of sharks that don't come to those areas. Maybe some of them don't come to those areas because that's not their kind of prey. But the ones for whom sea lions and other marine mammals are their kind of prey, you'll find them gathering in birth zones. So they also are finding places. I've just seen in some of this footage I've been watching, the guy says that the shark biologist says that great whites will come back to certain places on a regular basis. Sometimes places that there have been historical associations with prey animals, stingrays, whatever, seals, and that the sharks will come back, and come back. You know, they wander around in the daytime, and just around sunset they come back and they gather for a little while. Why would they do that? Well, there are a couple of reasons, and again, nose. You travel back to a certain area that it's easy to find. You follow the currents to it. You follow your nose to it. These things will stick with you. And when you get there, you'll know pretty quick if a shark is an estrus. You'll know if a shark is old. You'll know if a shark is bigger than you. You'll know if a shark is more aggressive than you are, less aggressive than you are. You'll know the females of your great white association will get used to you, so that there is less of a chance of you being preyed upon or warning bitten if you come in to see if one of them is ready to get mated. Great whites, the females outsize the males beyond a certain growth place, 11 years, something like that. Sexual maturity tends to make the females bigger. And the males, of course, stay more agile, but You and I, and people that are fascinated by sharks, are fascinated by great size in sharks and the big, big great white sharks, the biggest sharks that we know of other than whale sharks and basking sharks, which are ho-hum plankton eaters, are these giant great whites, like Deep Blue, they call the one shark, and she's a female. All of these giant great whites are females. Males don't grow that big. So if you're talking about a 7-meter PCL, that means pre-caudal length, it means without the tail flukes, because that's really not part of the shark so much for measuring it. You measure the shark down to where the end of the shark's bone and muscle structure go. You know, the crocodile, if the tail was just a flappy piece, we probably wouldn't include it in how afraid we are, you know, like a tadpole. However, these great white sharks need only follow their nose. That's it. Oh, something died over there. I can smell stingray poo over there. Seals are gathering. Now, you'll find that out by letting the waves carry you around pretty much. I mean, you may stick to an area. You may have some magnetic homing sense like pigeons do or other migratory animals might. But, in general, the ocean's going to carry you places. If you're going a certain way, the current's going whoosh. I've seen pictures of sharks in the water trying to go this way, and they're struggling like hell like this to go that way because the current's that strong. Imagine something as powerful and as streamlined as a shark having trouble navigating through water because the current is going in a direction it doesn't want to go. And so, most sharks, not wanting to spend all that energy unless they must, will go with the flow. So you follow the currents until you find places where fish shoal or seals gather, or you can smell those things happening. Or you know you'll find stingrays because you can smell them in there. You can smell them over there. Another place like that is very possibly kelp forests. Kelp forests are very attractive to a large spread of species that would prefer to not be eaten. If you're out in the open water, a lot of things can see you. If you're in a kelp forest, fewer things can see you. Of course, your dangers are more immediate because you'll come around a corner and now you're face to face with a predator instead of seeing them in the distance and they see you in the distance. And a stern chase is a long chase. So, well, great whites associated. This guy in Monterey has been filming a lot of great whites in the kelp forest. And that makes perfect sense to me. And I'm going to talk about a mechanism, a nose mechanism about this. But at any rate, some great whites really seem to enjoy, more than others at least, eating mammals, marine mammals. So sea lions, otters, dolphins, and doggone if you won't find sea lions and otters concentrating around the kelp forests off the coast of California, Oregon, and other places where you'll find them. Yeah. So you find sea otters, you'll find sea lions, and you'll find animals that like to eat sea otters and sea lions, great white sharks, and you'll find other animals that really like that ambience for whatever reason, stingrays, right? Certain kinds of fish, certain kinds of eel, and certain kinds of crustacean, which are the favorite foods of sea otters, sea lions, and whatever your local favorite flavor of predator is. Now, flipper, right, pass around a blowfish. Whoa, there's people say that's not why. Anyway, so a shark comes into a kelp forest, and you'll see footage of that shark just swimming serenely past all manner of potential prey. Yeah, and the guy taking the drone footage is like, why would they do that? You know, why are they just being so... Look, there's a shark going right past a stingray. And neither one is even acknowledging the other, but you can clearly see them from the drone. I mean, the water's clear as a bell. The animals can sense each other. They can see each other, too. No problem at all. So why is that? That was his sense of wonder opening. And here's my spin on what this is all about. A shark is driven by its nose. To be driven by your nose, you have to have a certain understanding of the nasal ambience of a region, or else you can't understand what your senses are telling you. So you need to swim through that region. La da da. Ooh, smells like stingrays over here. La da da. Smells like rocks over here. La da da. Smells like kelp. La da da. Oh, I smell octopus. La da da. I smell pollution. I smell all the things a shark can smell. I smell blood from this animal, blood from that animal. Something like blood from some other process, like cupric chloride or something. So runoff from the gold mining, runoff from silver mining. You'll find compounds that will attract sharks and all of that because blood has a major oxygenator, hemoglobin. Hemoglobin in the water tastes like iron. Well, it's a little nuanced because if you're a shark, your sense of taste is much finer than ours is. But you know, if you have blood in the water, it tastes like iron. If you sprinkle some iron in the water, it tastes like iron. So metals have a tendency to taste like iron, smell like iron. So if a shark smells metals in the water, it's going to want to check it out because maybe it's blood. Squid and octopi have different based blood. Mollusks, I guess, in general. And that's based on copper. And that smells different. And so they'll want to know. And they'll want to know if there are seals gathering. And they'll want to know if there are stingrays gathering. And they'll want to know if there are sea otters. They'll want to know. They'll want to know. And their major sensory apparatus is their nose. I mean, sure, they have a wonderful pressure sensing device all running along their body. They have a wonderful electronic sensor for electric fields like this running across the front of their snout. These are sharks do this. Ampules of Lorenzini. I act like I know something because I read a book. So these sharks that cruise through these areas peacefully, not preying, are getting a picture in their mind of the area. This is what this place is like. Here's where the currents want to take me when I'm in a place that smells like this. Here's where the seals are. If you follow your nose from here, you can find seals because you know the water's coming from here and that's where the island is. You don't know this, but you know that you'll smell seals in that direction if they're there. You'll know where the stingrays are. You'll know where people are swimming. You'll know these things. And you won't care until you're hungry. And when you're hungry, you're following your nose around. You're going, what's changed today? Where will there be something big and dead or big and living and doesn't struggle too hard or whatever your criteria are. And you'll follow your nose. And you get to some place where some animal is old or infirm, so it's giving off blood in the water. Or it's just given birth, so there's lots of blood in the water. Or it's in some other process. It's inverted its stomach and there's goo everywhere and you can smell the dead stuff in it. It makes absolute sense to me to think that in this wise a shark is merely an eating machine. It's a perfect eating machine and it doesn't have to eat every second of every day. It's not snapping at everything that goes by, but talk to an elasmobranch scientist or researcher and they will say, well, yeah, sharks have one major sensory organ, it's their mouth. And they test everything with their mouth. So if your arm can be pierced by a shark's mouth, something's going to happen. Blood. And now the shark's like, oh, this is perhaps edible. It may not have meant you any harm. It may have just said, here's something weird. Ooh, it's alive. It's warm. Uh-huh. Or it may say, it's not a fish. You know. So even though I like the idea of attributing a broader swathe of the definition of intelligence, especially in feeding strategies and acquired, learned, and transmitted behaviors, especially predatory behaviors, because that's where we can see them. We don't understand a lot of other social behaviors because we don't know. But we do know predatory and sexual behaviors because there they are, right there. Baboons going at it, a lion sneaking up on them. Wham, bam, here comes a lion, let's scram. You know, nature, red and claw, and erected penis. So, it is my contention that all a shark is doing is the most elementary thing that an animal can do. It's taking a sensory picture of its environment so that when that environment changes, it can say, that smells like something I should investigate, or, yeah, and just keep swimming. And it will say, yeah, I'm just looking today. I'm not eating today. You can go past me, little monster, because I'm just checking things out. But as far as food goes, active mackerel sharks, they need a fair amount of food. We can say, well, lizards and reptiles need less food than mammals do because mammals have a higher energy diet or have higher energy requirements, and reptiles have lower energy requirements, so that a crocodile might eat once a month, sometimes once a year, and they can survive that. They can do a thing called estivation, which means that it's like hibernating like a bear, except a different process. Your heart almost stops, and your breathing almost stops, and you lay there in the mud until the rainy season. It's a real thing. It happens. It's a mechanism. These sharks that I'm talking about, I think, are going to these places for very good reasons. There's no need to look for further mystery. They are driven by their nose, like a dog is driven by its nose, and they have a predator's curiosity. Something different, let's test it. Something different, let's test it. Just like dogs. Dogs mess with everything, don't they? Yeah. Now, a dog has a more complex brain than a shark does, but it pretty much is focused on the same sensory input as a dog is. Nose and mouth. It's how dogs interact with their environment mostly, don't they? I mean, they do some scrabbling and kicking and stuff, but mostly it's, right? And that's what sharks do. And they're very reasonable assumptions to make over this. Pardon me for saying reasonable and assumption in the same sentence, but that can be applied here, I think, to success. The shark is merely taking a nasal picture of its environment, so the next time it flows through it, it will have some idea as to what might be changed, as to what might be food. And also things like sharks, great white sharks are vulnerable to predation by orcas. I was fascinated to find this out. There are pods of orcas, that's the biggest dolphin, some of them grow 30, 35 feet long. It's big monsters. Anyway, but there are orcas, who specialize, whole pods of them, in preying upon sharks, because if you kill a shark and you split it open, which is easy, you can suck out its liver. And these whales seem to like that. But killing the shark means chewing on the shark, biting the shark. And sharks have skin called shagreen, which is composed of tiny little pointy things called denticles that are, in essence, teeth. So a shark is covered with keratinous teeth. So that wears your teeth down. I mean, it takes a long time to wear down the enamel caps, but the sides of the teeth are more dentinous and they wear down quick. So what happens in these killer whale pods that specialize in eating sharks is that their teeth all get worn down to the nubbin. But they're still able to feed. And that's interesting. That's acquired behaviors, that's taught behaviors, that's a matriarchy passing down these behaviors to its descendants. That's what I would call culture. It's done by communication. It's not done by instinct. So a shark needs to know things like, are there orcas nearby? A shark needs to know things like, if there are orcas nearby, are they the kind that eat sharks? Because not all orcas care about sharks at all. Many orcas will just float right past a shark. Hey, screw you, buddy. Others will stop and screw with it until they kill it because it's competition for tuna or whatever, but others will purposely seek out those sharks to bite them open and eat their livers. And you can tell which orcas those are because their teeth get worn down to the nubbin by the time they're 30 years old. Orcas live like humans, 75 years. And they're smart as humans. So what goes on in an orca's mind, you think? It can't be what goes on in our mind, because orcas never heard of Kardashians, and if they did, they'd think like, ooh, there's a human it might be nice to try out, because look at all that meat. Look at that big bump. I bet that makes a good bite. But We don't think like that. We look at Kim Kardashian or the Kardashian family or the whole experience of our pop culture, and we think this is wonderfully diverting, and otherwise our lives would be so desperately, dreadfully dull. Well, killer whales are thinking like something else, maybe, right? How could we know? Unless we see them do something that we can specifically orient to a definitive result. Preying behavior, mating behavior. Cultural inculcation. Do you think I jest? Lately, there's been video on YouTube available. I'm not sure if you guys can still find it because a lot of stuff's going behind paywalls now, but there was video on YouTube about a shark that got, or about a killer whale that got caught in a teeny little cove that's got like all these like rock walls between the ocean and this teeny little lagoon inside. It's like rocks all around it, mountains all around it, just this teeny little slot in the mountain wall, and it's got a big rocky thing, and you have to go in at high tide if you're an orca because you're a big animal, and you can't get out at low tide. Those people like come in with a helicopter, and the orcas in the videos I've seen look very much like the females are teaching the young to navigate this slot. What do they find in there? Well, they find a nesting spot for seals in a place where there isn't much beach. So the orca has a fairly good chance of snagging him or her a seal. And that is yum yum. Seals are yum yum. Think about if you're an ocean predator and you got a mouthful of teeth, and if you're either a shark and got gills or you're a whale and you got a dicey digestion, you don't want to be eating a lot of bones. See what I mean? Unless you're specialized in bone crushing like T-Rex. You don't really want to be just munching down bones. And since you got no hands and there's nothing to push stuff against like lions can to like pick their spot, you're kind of stuck with like whatever you get. And if you bite a human, you're going to get a leg, an arm, ribs. That's a lot of mess, and there's not much good stuff for the human. It's all right here. All the rest of this is just not even roughage, it's just stuff that gets in the way. And a shark could go through their gills and wound them, kill them. So when you're an ocean predator, you're looking for something that has a lot of nice guts in it right there in a spot where it's not very protected. And then you don't care about the rest. Like the orcas that eat the livers. They just suck them out like sperm whales suck squid. Once they split it open, you get a young male to do that. Yeah. But then you can just like, you know, the females or whoever the other orcas are can share. They all suck out some liver. Now, these are things that I find extremely cool. Not cool because I want to be a shark or because I want to be an orca. Neither lifestyle seems to agree with me. But I will say this about a shark figuring out its ambience. Orcas, though this is something I got out of a paper I read, not sure if it has been, well, it's been peer reviewed obviously in the publication I read it from, but I'm not sure how much of this has been corroborated by a subsequent study. But from the paper it seems very evident that there are two kinds of orcas close enough to the coast that you can worry about them. There are the residents, who are the locals, and there are the transients, which are the ones that cruise up and down the coast. The residents, if I understand the papers correctly, because several papers have alluded to these means, the residents don't eat mammals. They eat fish. They eat tuna. They're like wherever the sockeye come out and go back into the rivers. They go places where they know they'll find mackerel and tuna and big fish they can eat, right? And then there are the transients. The transients roam up and down the coast. They're the ones that go for seals and sea lions and elephant seals and dolphins and whales that come in close. Now, there is another kind called, I think they're calling them provisionally hobos, type C. It's like type A, type B, type C. But I think that the vulgar reference for these particular types is hobos. And these hobos are the ones that follow the great whales in their migrations or intercept them at certain points in their migrations and intercept them as they leave the birthing zones, you know, with the young calves. And these orcas have specific preying strategies that are designed to tire and drown great whales. The ones that feed on sharks aren't like that at all. They have a different, they turn them over, they do tonic immobility. It's amazing. It's just incredible that an orca would be able to pass that along. Hey, if you turn a shark over, it'll imagine. That's culture, bud. The matriarchs teach that to the young. And the young start performing those behaviors, and the whole pod now is specialized in turning sharks upside down to make them go like this, to make it easy to crunch out their livers. They don't fight. They don't bite you. Shark bites you, it could hurt. I mean, even with all your blubber, a big gray white shark or a big tiger shark could take a sizable chunk out of you. And what if it bites a sizable chunk out of your flukes? You're dead in the water. So even a killer whale, even an orca that's much bigger than the biggest predatory shark, still has to worry about those sharks when it competes with them or preys against them. Now, for their part, sharks follow whale pods, as I said. And so a shark will find a dead baby killer whale. Didn't quite make it. Well, sorry guys, but you know, nature, red and claw and erected penis. Something's got to break. Something's got to give. Somebody's got to get a little something, something, or a little something, something, right? Now, this all makes sense to me now. I was wondering about why sharks are seeming to show certain behaviors certain places and other behaviors otherwise. Why does Deep Blue just cruise past the shark cage even though it knows that there's animals exuding blood in there? Because she's following her nose. There's the chum ball. Oh, blood through your gills. That must feel good to a shark, right? That's how you taste. And then you like cruise around and there's this weird smell you're not used to. It's very metallic, so it could be blood. Cages are metallic. And that means they give off ions in the water. That means it smells like blood. And then the people around the cage up on the boat, they're chumming the water and throwing bait balls down to bring that shark in. And she's thinking, that's interesting. I wonder what that's like. I wonder what that's about. Can I mate with it? Can I eat it? It's her basic drives, right? And if she's not in the mating cycle in the right spot, she won't be interested in mating with it. So there are only two things she could be there for: preying behavior or sampling the sensory ambiance of an area for possible inhabitation or cruising through for prey. And you can't do that without knowing what the area smells like first. So that if a prey animal runs across, you can smell, oh, something new, something changed. Or something's really stinky. One of those things that was over there died. Yum, yum. That's good eating. So, I think the sharks are very, very much run by their noses. And their noses tell them everything. And their inhibitions against predation amongst their number are due to their noses and these inherited behaviors as to what you do with the information your nose gives you. You're like, something big, something alive, something, oh, it's another shark. And that's what I see in those films. They get close enough they can make visual contact, like, I don't think so. And then the little ones will turn around and follow the big ones, and you wonder why. That's stupid, right? No, those are males, and they're following in the trail of the females to see if they're in estrus. Makes perfect sense, doesn't it? Young, scenting to see which is a new creature and which is an adult of their own species. Protective mechanisms, predation mechanisms, socializing mechanisms, all based on that smell. Okay, well,